All right, so here we are on page 22. And what I am showing is exactly what you need to show on tests and quizzes if you have to do free response. If you have to graph something on free response, there's no extra things that I'm showing on here. You have to show this exactly. All right, so on page 22, what we are doing is we are going to start translating just straight review from Algebra 2. So I'm going to use my little Post-it right here because my Post-it note is my mapping on my translations. So number 1 says to translate the quadratic function 3 units up. Number 1a, A says to write the parent function. The parent function is y equals x squared. So that's part A. Part B says to write the function for the transformation. If it's translated 3 units up, it is a k value, not h. K is never in groups. So I'm going to write y equals x squared, and then my k value is just plus 3. So now in order to graph it, we have to know what hk is. Since we did not have any horizontal translations, the h value is 0, the k value of course is 3. We're going to plot that ordered pair, go 3 places above the origin, draw a dot. 2, 3. And then remember, not only are these ordered pairs on the parent function, these are also maps from the new hk. So the new hk is here. I'm going to go 1 place to the right and 1 place up and draw a dot. That's on the graph. Let's go back. You always go back to hk. Now I'm going to go in the negative direction, and -1 times -1 is positive 1. So we go 1 place to the left and 1 place up and draw a dot. And then the next thing we're going to do is we're going to go 2 places to the right of the vertex. What's 2 times 2? 4. So we go over 2 and up 4. 1, 2, 3, 4. Same in the negative direction from the vertex. We're going to go 2 places to the left. -2 times -2 is positive 4. So there we are with the shape of our graph. Guys, when you are shifting from Algebra 2 to Pre-Cal, your graphs have to reflect that. They have to look neat, they have to look clean, and they have to have arrows on the end. If you do not have arrows on your graph, just don't ever expect to get full credit, guys. Make sure you have arrows on your graphs. That's it for number 1. Do you have any questions on number 1? All right, let's roll on to number 2. For problem number 2, we are using the greatest integer function, so my little mapping isn't going to help. The greatest integer function is the longest one to graph. We're only going to do it once. You need 2 separate colors for this. If you have 2 separate colors, let's get it out. So the greatest integer function, if you remember, the greatest integer function, don't write this because I'm writing the parent. You had a closed dot on the origin, and remember you had an open circle right to the right of it, and it was filled in. That's how it looks for the parent function, but remember it's being translated. It's being translated 2 units to the right and 1 unit up. So that closed circle that is at the origin, I'm going to translate it. 2 places to the right and 1 place up. That's where you need to start with one of your colors. You got to chill out on the talking, like it's just not going to happen. I've said that twice. So draw a closed circle, +2, +1. And then go directly 1 place to the right and draw an open circle. And then connect them. That's where the translation starts. If you do not have another color, then you need to circle this. And you need to draw an arrow to let me know that's where you're starting. Because once we fill it in, I have no idea, and you'll see. I'm done with that color. I'm going to figure out what other color I want to use, which is this crazy brown. Brown is cool. Now, guys, this open circle are going to have all open circles on that diagonal. So if you notice, the greatest integer function is going to continue with open circles on the diagonal going up and going down. Just be careful. Don't let your eyes jump because you might accidentally write open circles in the wrong spot. And then my closed circles are going to be along the diagonal of the first closed circle I drew. So I'm just going to go up and down, draw these closed circles. Then I'm going to go back and connect them where they look like steps, and that's going to be it. Again, this one, oopsie, I messed up. This one takes the longest. We're only going to graph one of these today, just this. And as you can see, guys, once we start filling in this coordinate grid, if I did not have a different color to see the starting point, it would all look the same. So use a different color if you can. If you can't, don't worry about it. Just circle it and let me know. Any questions on that? Yes, ma'am.
So on a test, you would want just to circle it and tell you that it's the starting point?
Yeah, but if it's my test, I let you use different colors. Like if you have to, we'll talk about that. I prefer you to use different colors. All right, let's go down to problem number 3. On problem number 3, we're going to transform the absolute value equation. So this is going to be helpful for me. So we are going to be looking at this column right here for the absolute value. Remember that goes to the origin, the parent function does. The ordered pair 1, 1. The ordered pair -1, +1. -2, +2. And +2, +2. Notice all of my outputs are positive because we are dealing with the absolute value function. So the absolute value parent function looks like this. Write y equals, and then the x in the bars. And then let's go ahead and figure out what's going on with our transformations. You have 2 transformations on this. You have a translation of 3 units to the left and 4 units down. So my brand new HK is -3, -4. However, remember your H is always opposite inside the groups. We're dealing with absolute value, so I know the vertical bar is my group. So it's going to be y equals, and y'all, we need to write x plus 3 in there. And then -4. Let's go ahead and plot our vertex at -3, -4. And then we are going to use this mapping. We're going to go over 1 and up 1 in both directions. Go back to your vertex and go 2 places and then 2 places up, 2 places to the left, 2 places up. And then, guys, I'm not drawing any more dots. I'm just going to use my ID and make my straight edges. So your ID makes wonderful straight edges, especially since your mean pre-cal teacher is making you draw a graph from edge to edge. Maximize the space. That's a requirement. In pre-cal, you got to make your graphs look sophisticated. No baby squiggles. When I say edge to edge, the edge of the picture, one side to the other, guys. Don't forget your arrows so you can get full credit. Any questions on number 3? On number 4, we are going to analyze the square root function. So we are going to use our little diagram here. We're going to use this very last column. Guys, for the square root function, if you notice, all of my inputs were perfect squares because the outputs were the roots. I don't want to put something weird like 5. I don't know the square root of 5. So we're always going to move perfect squares so that our outputs are whole numbers. All right, so the square root function, remember the input is going to be having the square root to get the output. So the only transformation we have here is a reflection across the x-axis. That's upside down. So if a reflection is upside down, which values are changing? The x-coordinates or the y-coordinates? Just the y's, that is correct. So it is going to be y equals the opposite output. So we need to have a negative, and then we're going to draw our square root symbol. All right, guys. So you can take the square root of 0. So we're going to start our graph at 0, 0. And then the first perfect number in our number system is 1. So I'm going to go one place to the right. And usually the square root of 1 is 1. But we need the opposite. What's the opposite of positive 1? Yeah, go over 1 and go down 1, guys. Go back to our vertex at 0, 0. What is the next perfect square in our number system? So go 4 places to the right. And then remember the root's 2, but we want opposite, so go down 2 and draw your next dot. Let's go back to the origin. How many am I going to the right now? That's right. Good. And then don't forget to climb down 3. Draw your little branch, and please don't forget your arrows so that you can get your credit.